All right, hi everybody. So in this video here, we're going to take a look at another example of dividing polynomials. So I've got x cubed minus 7x squared plus 7x plus 6. And I'm going to divide that by x plus 2 here, this little binomial. Now, because this is in the form x plus a, this little binomial here, that is really well suited for synthetic division. So that's the method that I'm going to choose here. So I'm going to drop my box. And then I'm going to list off in my box here the coefficients of the dividend here, which is going to be your x cubed minus 7x squared plus 7x plus 6. Now, we're going to do this in decreasing order here. So the coefficient of x cubed is going to be 1, and then negative 7x squared, 7x, and a 6. If one of those degrees was missing, I would put a placeholder of 0 in there. Now, what I'm going to do is I take a look at my divisor here and I think, okay, what number would make that equal to 0? And the answer here is negative 2. So basically, I'm changing the sign. So you're seeing this x plus 2 in the divisor, I should say there. I'm going to drop a negative 2 out front. You could put a positive 2 out front. I'll tell you how that changes things in just a moment here. So now the way my procedure works here is the very first thing I'm going to do is I'm going to take that first coefficient. I'm just going to drop it right down so I get a 1 here. And now what we do is we multiply. So negative 2 times 1 is going to be negative 2. I'm going to put that right here. And here's the difference. Because I changed the sign on that 2, now at this point here, I am simply going to add. Okay, so negative 7 and negative 2 is going to give me negative 9. If you had chosen to put a positive 2 there, then when you've multiplied through, then your operation would have been subtraction. One way or another, you have to deal with a negative in there. Either it's going to be changing the sign on that divisor or implementing a subtraction. But one way or the other, it's got to happen. So the next thing that we're doing is we're going to multiply that negative 2 by that negative 9, and we're going to get positive 18. And then again, I'm going to add, and that's going to get me 25. And then I do that multiplication again. Negative 2 times 25 is going to be negative 50. And when you add those together, that 6 and that negative 50, we are going to get negative 44. And now we're done. We've reached our final column of numbers here, which means this value right here is my remainder. And this is my quotient. So my quotient here, which is typically going to be a function of x, doesn't have to be, but function of x here. It's always going to be a function of x if that's the variable up there, but it might just be a constant. But in this case, it isn't. This is my constant. This is my linear term. This is my quadratic term. So it's going to be x squared minus 9x plus 25. And my remainder function, which could also be a function of x, but in this case, it's just negative 44. So now that for some of your teachers, that might be enough just to identify the quotient and the remainder. Or you might have to go back up and write this in kind of a division statement form here. So you might say that your quotient here is x squared minus 9x plus 25, but that's not quite it. Plus, there's this little bit left over that I wasn't able to divide out. It's that negative 44 over that x plus 2. That little bit of division still needs to occur. And there's a division statement. There is another way to write the division statement, just in the form that I've got it right now. That's not where I'm headed. You're just going to have to figure out from your instructors what is it they're expecting you to do. But this is how I would approach the division like this using synthetic division.